Hello and welcome to another Common Core Algebra 1 lesson by eMathInstruction. My name is Kirk Weiler, and today we're going to be doing Unit 2, Lesson 10 on compound inequalities. Before we begin, don't forget that the worksheet and a homework that go along with this video can be found by clicking on the video's description. As well, remember the QR code on the top right-hand portion of every worksheet. Use your tablet or your smartphone to scan that code and bring you right to this and other videos. All right, let's get into it. Last time, we talked about inequalities and how to solve linear inequalities. We also talked about just generally the true-false nature of inequalities. Today, though, we're going to be getting into more complicated inequalities, what are known as compound inequalities. That's what happens when you put two inequalities together using either the word and or the word or. Sorry, I know that could be a little bit confusing. What I'd like you to do is I would like you to look at each one of these statements and think about whether you consider the overall compound inequality true or false. All right? To do that, you first might want to think about whether each of the individual ones is true or false, and then think about what you understand in terms of the words and the words or. All right? So pause the video now and take about 5 minutes to do this. All right? Don't worry if you're wrong. Don't look anything up on Google. Hopefully your intuition and what you already know about inequalities is going to get the job done. Okay? All right, let's go through them. Letter A, 7 is greater than 3. Well, that's true. 2 is less than 10. Well, that's true. So if this is true and that's true, then overall, this is a true inequality, right? It's kind of like saying to a friend of mine, hey, it's Saturday today and it's raining. The only way that statement is going to be true is if both of the things I said were true. All right, let's take a look at letter B. 5 is less than 10. True. 11 is greater than 20. False. Now, if I said today is sunny and it's Friday, and one of those things was wrong, one of those things was false, then you would say overall I'm lying, right? And implies that they both have to be true, right? Let's take a look at or. -4 is less than 7. Well, that's true. 8 is less than 2, and that's false. Now, if I said, well, I'm a math teacher or I'm an English teacher, because I'm a math teacher, well, that makes that overall statement true, right? When you have an or, only one of them really has to be true, right? So, overall, I would call that a true statement. 3 is greater than 6. That's false. Or 8 is less than 5. Well, that's false. So that's like me saying, well, I'm an English teacher or I'm a professional ballet dancer. Don't picture it in your head. It's not worth it. So, because both of those are false, overall, I'm lying, right? I mean, if I say, hey, look, I'm this or I'm this, and both of them are not true, then you would say, no, you're lying. That's false. All right? So far, I think just our intuition about how the words and the words or are used leads us to get the right, true, and false nature of these inequalities. But now let's go on to one that's a bit confusing. Okay, so I'm going to clear this out. Pause the video if you need to. All right, here we go. The only thing that's really confusing about compound inequalities is what comes next. Consider the compound inequality 8 is greater than 2 or 3 is less than 10. It says determine the truth value of each of the inequalities in this compound inequality. So 8 is greater than 2. Well, that's true. 3 is less than 10. Well, that's true. All right, now remember we have an or here, not an and. What does your intuition tell you the truth value of the compound statement is? What is the mathematical truth value? All right, so don't worry about the rest of it. I want you to pause the video, right? If I said to you, hey, 8 is greater than 2 or 3 is less than 10, right? Would you claim that that was a true statement or a false statement? Think about it a bit. All right. Well, in most of our everyday sort of like use, English intuition truth value, right? We would say that this is false, right? Because most of the time, the way that we use the word or, and that's the important thing here, not and, the way that we use the word or in the real world is that when I make an or statement, I'm using what's called the exclusive or, meaning that, look, if I tell you I'm a math teacher or a professional soccer player, right? Well, then only one of those two things can be true, right? It's this is true or this is true, right? But the plain fact is that in math, the way that we do an or statement is what's called the inclusive or, which means that when I give you an or statement, that an or statement will be true if at least one of the two statements or three or four statements is true, but they can also all be true. So an or, the better way to think about it, the only way an or will be false, the only way an or will be false is if all parts are false. That's kind of the exact opposite of the and, right? The only way that an and will be true is if all parts are true. The only way an or will be false is if all parts are false. And that can be very, very confusing because it is not the way that we typically use the word or in our normal everyday language. If I tell you you can have ice cream or cake for dessert, it doesn't mean that you're getting both of them. Or at least it doesn't mean you're getting both of them from my kids, right? So anyway, then again, maybe it does mean they're getting both of them because I'm a math guy. So I'm going to clear out the text. Go ahead and write down what you need to and really come to grips with that or. We're going to summarize it in just a second anyway. All right, here goes the text. Okay, so let's try to put that thing to the test right now. Which of the following compound inequalities is false? Explain your reasoning by showing the truth values of each of the individual inequalities. So we're going to go through every single one of them, but we're looking for the one that's false. Okay? So please work on this. Pause the video if you need to, and then we'll talk about it. All right, let's go for it. I don't know how you could not need to pause the video. Unless you can do it really, really, really fast. Okay, here we go. So in the first one, we have 5 is greater than 2. That's true. 4 is less than 1. I don't know why I just put 3 there. That was kind of funny. 5 is less than 2. 5 is greater than 2. That's true. 4 is less than 1. That's false. But because it's an or overall, it's true. All right, the only way an or is going to be false is if all parts are false. Choice 2, -6 is less than 5. That's true. 7 is greater than or equal to 7. That's true. Now, the only way an and is true is if all parts are true, but those are both true. Number 3, 10 is greater than 0. That's true. Or -3 is less than 9. That's also true. But that's completely okay. Right? The only way an or is false is if all parts are false. Since those are both true, it's still true. So 4 has got to be the right answer, but let's walk through it really quick. -2 is less than or equal to 4. Well, that's true. And 5 is greater than 7. Well, that's false. The only way an and statement is going to be true is if all parts are true. And again, that at least fits our intuition. If somebody came up to you and they said, hey, -2 is less than or equal to 4 and 5 is greater than 7, you'd say, no, it's not. And I'd say, why? And you'd say, well, because 5's not greater than 7, right? There it is. All right, I am going to clear out the text, so pause the video now if you need to. All right, here we go. Let's move on to the next problem. Truth values for and or. A compound and statement will be true only if all the individual statements are true. All right, all statements are true. A compound OR statement will be true if at least one of the individual statements is true. Or another way of putting it, OR will be false only if all parts are false. Okay. This is going to be important for geometry next year, but it's going to be important for us this year when we solve compound inequalities, which are coming soon, and when we solve systems of equations and systems of inequalities. All right, so I'm going to clear out this text. Here we go. Let's do some problems. Solution sets of equations and inequalities. Now, we already have seen this before, but it's very important that we talk about it again. A value of a variable is in the solution set. Solution set is the collection of all things that solve the equation. So a value of a variable is in a solution set of an equation or an inequality if it makes it true, and it's not in the solution set if it makes it false. Now, I really, really want you to absorb that. Algebra is much bigger than just a collection of random techniques for solving equations and inequalities and annoying word problems, right? Algebra is about bigger ideas and bigger truths, and this is the biggest one of all. Equations and inequalities have solution sets. Sets are just collections of things. So a solution set is a collection of numbers that make either an equation true or an inequality true. A number that makes it false won't be in the solution set. Okay, so clearing this out, I think we've harped on that point enough, and let's move on. Determine if each of the following values of x is in the solution set to the compound inequalities given below, and we justify our answer. So watch, letter A, simple enough. Is x equals 2 part of the solution set of x is greater than -3 and x is less than 5, justify your answer? Well, it's this simple, watch. 2 is greater than -3, well, that's true, right? It lies to the right of it. And 2 is less than 5. Oh, let me put the word and in here. And is very important. Well, that's also true, right? And will be true if both parts are true. So this is a true compound inequality, which means that yes, it is part of the solution set. Let's take a look at letter B. Is -4, x equals -4, part of the solution set of this compound inequality? Well, let's test it. -4 is less than or equal to -4. That's true. Or -4 is greater than 0. Well, that's false. Now watch out though, this is an OR statement. So, right, ORs are only false if everything is false. So this is actually true, right? Because one part's true, which tells us that the answer is again yes. Now, a little bit trickier. Well, not trickier, but just more, right? So is x equals 1 part of the solution set of this system of inequalities? Well, let's check. 3 times 1 plus 8 is greater than 9. 3 plus 8 is greater than 9. 11 is greater than 9. Yes, that's true. -2 times 1 plus 10 is less than 7. -2 plus 10 is less than 7. 8 is less than 7. That's a big fat F for false. And what do we have? We have an and. So for an and, these both have to be true. So this is actually a false compound inequality, which means the answer is no. It is not part of the solution set. All right, let's do one more. 2 times 5 minus 1 is less than 3. 6 minus 1 is less than 3. Oh, where did I get 6? I have no idea where that 6 just came from. That was weird. All right, 2 times 5 is 10. 10 minus 1 is 9. 9 is less than 3. That is definitely false. Let's try this one. 5 plus 7 divided by 2 equals 6. 12 divided by 2 equals 6. 6 is equal to 6. Well, that's true. Now that's an OR. Okay, it's really hard to make an OR false. It really is. They both have to be false. And since one of them's true, then overall it's true, which means that yes, it is part of the solution set. All right, so critically important to understand this idea. If a value of x, or whatever variable, makes the overall inequality or equation true, then it's part of the solution set. And if not, it isn't. Okay? So I'm going to clear out this text, pause the video for as long as you need to really try to understand this. All right, here we go. All clear? And now, the next problem. Okay, final problem. On the number line below, we're going to shade in all values of x that solve the compound inequality. In other words, shade in the compound inequality's solution set. Right? We want to shade all the values of x that make it true. If you need a good place to start, try listing some values of x that make the compound inequalities true. All right, well, let's take a look at this. Here we've got an and. So I need some values of x that make both true. All right, very important. Well, let's see. How about x equals 6? 6 is less than 7, and 6 is greater than negative 2. Awesome. How about 10? No, 10 is greater than negative 2, but it's not less than 7. That doesn't work. How about negative 5? Negative 5 is less than 7, but it's not greater than negative 2. How about negative 1? Negative 1, yeah, that's less than 7, and it's greater than negative 2, so that's good. Try another positive number. How about 4? 4 is less than 7, and it's greater than negative 2. Great. Hey, let's take a look at something. Less than 7, that's going to be these numbers, right? So this is x is less than 7. Negative 2, that's going to be these numbers, right? And means they both have to happen. And they both happen for all values of x in here. So here, open circle, is the solution set. Right there. Isn't that kind of neat? All right, let's do one with OR. Now for OR, at least one has to be true. Both could be true, but at least one has to be true. This is actually kind of easier. Let's see. Let me make this one true. Let's see. 5 will make that one true. So will 6. So will 7, etc. All right, they'll make these false, right? Because 5 is not less than negative 1. 6 isn't less than negative 1, but that doesn't matter, right? We just got to make at least one of them true, which actually means that like numbers like negative 2 and negative 3, etc. will also work because they're less than negative 1. In fact, what does less than negative 1 look like? It looks like this, right? This is the greater than or equal to negative 2. This is my x is less than negative 1. Here's my x is greater than or equal to 5. So we're not looking for the overlap. I don't want where both of them will be true. I actually just want where either one of them is true. There's actually no values of x that make both of them equal to true in this. There are no values of x that make both of them true in this case. Okay, so this is actually my final graph. All right, we'll work with more of that next time when we do more work with compound inequalities. For right now, I just wanted to give you a little bit of a taste for it. All right, I'm going to clear this out, so pause the video if you need to. Okay, let's wrap. All right, so today what we did is we looked at compound inequalities. Very importantly, we looked at the words and or to try to really understand what makes things true for an and statement and what makes things true for an or statement. At the end of the day, it's this simple. And will only be true if everything is true that makes it up. Or will be true, or will only be false if everything that makes it up is false. All right? Anyhow, thank you. Thank you for joining me for another Common Core Algebra 1 lesson by eMathInstruction. My name is Kirk Weiler, and until next time, keep thinking and keep solving problems.